So welcome back to our class. Want to this time look at Noir. That is a programming language that is used to write zero knowledge proofs. Last time we were looking at SACOM. We are now done with the SACOM. So in this lesson, look at how to install Noir and then how to use it in writing zero knowledge proofs. That is our target in this lesson. We want to learn more how to use it in writing zero knowledge proofs. Now, so just before we install it, I thought it's necessary just to know what Noir is. And I've said it's an open source, domain specific language designed for privacy preserving and the construction of zero knowledge proofs. So it's designed for writing zero knowledge proofs. So it's a very important language for us. There are so many languages that I use to write zero knowledge proofs. This is one of them. Now, the advantage of this of Noir is that it user-friendly mathematics in cryptography. It does not require a lot of mathematics. It does not require prior knowledge of lots of mathematics for you to understand how to write it. Although the mathematics will be necessary in some cases, but not very much important. So that means if you've not done a lot of math in cryptography, you can still understand how to write Noir and use it. Now, so we'll be using it to write proofs without necessarily revealing the inputs. So you know that is what we do in cryptography. We want to ensure that you, for instance, you want to prove somebody you know what Z is. Supposing Z is a product of these two numbers, X and Y, you want to tell somebody you know what Z is without necessarily revealing Z. So in so doing, you also not revealing what X and Y are. So that's what we want to do. That is what we shall be using Noir to do, writing zero knowledge proofs. So that at the end of your proof, you've not revealed what Z is. That is what it does without necessarily revealing any inputs to the statements. Now, so the inputs and the outputs will be from field elements. We know what a field is. For instance, when we talk of ZP, you know what that means. This is a field. So what a field, let me just remind you what you are doing in a field is that whenever you are to do addition, for instance, inside this field, let me say you're adding N and B, whenever the sum would come to P or more, it will round off. That is what we mean by a field. So for instance, supposing we are in Z7, and then 3 plus 5 would be 1. So because this is 8, and now when you reach 7, you round off. It's like a clock, so you begin afresh. That means 8 minus 7, that gives you 1. That is a field, that's what a field is. So we'll be dealing with the elements of a field. Elements of a field, that's what we'll be dealing with. And that is what Noir uses. So the inputs and the outputs will always be elements of a field. We already did about so much about fields, so we have no problem with that. Now, so again, just to again talk about elements that we'll be using, they will fall in two categories, the primitive type and the compound type. So what are the primitive elements? So when we talk of primitive, what we just mean is that this will be, we include the fields, integers, and bool. But the compound type of data would be a group of the primitive types. So if you have the primitive ones and then a group of that, if you are to group them together, and then that is what we call compound. So that would mean arrays, tuples, and the structs. That's what I mean by compound. So the data in Noir would be in these two categories. Now, whether primitive or compound, again, when you're writing zero knowledge proofs, we want that some of these data will be private. That means only the person writing knows them. They are not revealed to the public. And some of the data will be public. That means even the verifier gets to know what it is. Supposing you are the prover, and you are writing your zero knowledge proof. And then we have the verifier. The verifier wants to know whether you really know what Z is. You are the prover. You must know, you claim to know what Z is. So the verifier wants to know whether, wants to verify whether indeed you know what Z is. So while you're writing a zero knowledge proof, you want to keep some elements private. You want to keep some elements private. You don't want the verifier to know what they are. And some of them, you would keep them public. That means the verifier would get to know what they are, and so on. So that means what I've just said is that the data we'll be writing would be comprised of private and public entries. And so that when you're writing it, you specify. When you don't specify in Noir, when you don't specify, and then it becomes private. When you don't specify, by default, it is private. But when you want it to be public, you must specify. You must specify for it to be. You must specify that it's public. You must specify that it's public. When you don't specify that it's public, then by default, it is private. So I've said a private value, also known as, is only known to the prover. This one I had already said, the private is only known to the prover, while the public one will be visible to the prover and the verifier at the same time. So the verifier gets to know what it is. So that is a public value. So, and again, I've said that when you're writing zero knowledge proofs using Noir, you would want to specify which one is public and which one is private. So, but I've said that if you don't specify that it is public, then by default, it becomes private. By default, it becomes private. So if it's not specified to be public, then it's private. But if you want it to be public, then you must mark it as public. You must mark it. So you mark it public once. And we saw when you were writing the SACOM language, we saw how to make it public, and we saw how to make it private when we were writing SACOM. And again, when you're doing this, you'll be seeing how do we write it private Now, how do we write it public? Because when you don't specify it, it automatically becomes private. But if you must specify some addition how to do that. Now, so after that, you'll be using a Noir language in doing so many things, you're doing smart contracts and so on. There's so many things you can do using this language when you are doing it in zero knowledge proofs. Circuits, we did that, and of course, we'll be doing this now in Noir using Noir language. We did that when we were looking at the R1 CS. We wrote circuits. Then we also written circuits when we are looking at circum language. And again, we will do this now using a Noir. Of course, we know what a circuit is. So our aim is now just to know how do we write it. Now, in Noir, the private values sometimes are referred to as witnesses. So when we talk about witness, and of course, when we are looking at circum, we saw what a witness was. To be slightly different from a witness this time around, slightly different, but of course, again, it is saying how to come up with a witness. Supposing you are the prover, you want to prove to the verifier that you know what is. So then the verifier looks at the witness and verifies whether it is correct. So that's what will be happening. Now, I've tried to, again, to just look at the meaning of private and public. And again, this will depend on different scenarios or different contexts. Because I've said, for instance, when the words are applied to a field, a type, when they are applied to a type, a public field, the word public field will then mean that this entry is visible to the verifier. When it's applied to the public, the type, then it means it's visible. It's visible to the verifier. But when it's applied, when the word public is applied to a function, when the word public is applied to a function, and we know what a function is, for example, when you say pub and then the function you're writing your language is you know what this function means. Let me say, now when it's applied to this function, look at this. This one is, the word public was applied to a field, pub field. So it means this field is public. This field is public, and that means this field, the verifier should be able to see what it is. But now, pub function. Now, this one does not mean that the function should be visible to verify. It does not mean that. What it means is that this one will now control accessibility from other Noir programs. It just controls accessibility from other Noir programs. So that is what it means. So it does not mean that this function now becomes visible. But I've said the public, when you are referring to public function, not a function, if it's applied to entries, and entries in this case, we said that the members of a field. If it is applied to entries, then we just mean that this entry is not hidden from the verifier. The verifier should be able to know what it is. But sometimes you could use the word public before a function. And that one does not mean that this function should be visible. It does not mean, but it just means that this will now be controlling accessibility from other Noir programs. Now, just an example of how to write uh, some circuits using Noir. You have function, main, then inside this main you have entries, and you're saying that this entry, first entry X, is a member of a field, and this other member Y is also a member of a field, but I want it to be public. I want this to be public. Y should be public. But X, you can see there's no word public here. So we've said by default, when the word public is missing, then it means this X will be private. That means the verifier is not able to see what X is, but the verifier will be able to know what Y is. And again, you can see that this public field, this is the output. The output. So the output should be a field. It should be public always. Always the output should be public. Now, so what this function does is that it does the summation of X and Y. So it is doing the summation of X and Y. This X is private and this Y is public. And again, after you've summed these two, the outcome is also public. The outcome will also be a member of the field, because if X and Y are members of a field, their sum will also be a member of a field. That is a rule that we know from our previous knowledge. Now, so very important, this is an example of a circuit written in Noir. Just to understand what it means. X is private. I've already explained that. X is private. Y here is public. Y is public. I think that one I missed it. Supposedly Y is public. Y is public. And the sum of these two will be the output. Oh, I think what I did, I said Y and the output are public. Both of them are public. That's why when I left it from, when I did not mention it here, I said while Y and the return value are both public. Now, so it's good to understand it from the very beginning. I've already said that when you're doing this and you're writing, and whenever there's a return value, the return value is always good that it's public. And I've said here, note, public types can only be declared through the parameters of the main function. This is the main function. So you declare your public values here. That's why you declare them. This is different from how we were doing it in SACOM. Because in SACOM, this is not the point we were declaring which one is public and which one is private. Now, so you may even decide to have this and this both private. So if you want to do that, if you want this is private and this is private, you only omit this word pub. You only omit the word pub because this is what it means. This is what makes Y to be public. So when I omit it, then it means X and Y will be private. But now I've already said that the output must always be public. Now, again, I may want this X to be public. I include the word pub there, and I may also want Y to be public. And again, I include the word pub here. So Our entries can be both private or both public, or they can be a mixture of private and public. So there's no problem. It depends on what you want. Our entries can be both public, can be both private, or can be a mixture of public and private. But I've said the output, if there is, because there are cases when there's no output, when you don't want an output, there are cases when you don't want an output. And so, but if there is an output, then it must be public. Now, so before we go deeper, before we go deeper, it's good we first of all install Noir for those who not installed, so that then we can progress, so that we can proceed with practicals, hands-on. We do it practically to understand. Now, before you install Noir, the first thing you would want is that you need to have installed Rust, because how we write, we use Rust to write it. So first of all, you install Rust. Now, I know that most of you have Rust already installed, so that means this step would then skip it. But if you've not installed, then I'll show you the steps of installing Rust, and then we proceed to installing Noir, and then I proceed to using it. The environment that is required for installation of Noir: one, you require the Ubuntu Linux native, or you can do it through WSL. You also need a Unix like terminal. These are just what you require, the environment required. So the first step, if you've not installed Rust, this is the step for installation of Rust. You can install Rust. You open WSL. Your WSL, when you open it, you can paste this, and then it will download the Rust installer and then guide you through Rust installation. So once you click this, it will just download Rust installer, and then when you click on the installer will guide you through the process of Rust installation. So just follow the on-screen instructions, and you can install Rust. It's not complicated. It will just be guiding you through the process. After you've installed your Rust, you can restart your terminal or the WSL. And then after you restart, you can now update Rust to the latest version. And even for those who already installed it, you may just want to update it. You're still in your WSL. You just type or copy Rust update. Then it will just update your Rust. After you've updated, you can still restart your terminal. This is just to ensure that all the tools required are available for the next session. Because the next session will now be using this Rust in writing your programs. So when you restart, then it ensures that all the tools will then be installed or will now be available for the next session. Now, majority of you already have Rust installed, so that means begin is here. This is where we begin. We now want to install Noir. So let me just now open or I can take you through the steps, then we do it practically. The first thing, after you open your WSL, open your WSL, or you can open your command prompt. This one you just at the start you just type at the start. When you type command prompt, it comes, so you can click that, and then when it opens, that is where we now begin. You can do that, or at the start you can either type command prompt, or if you don't want that, you can type cmd, or if you don't want that, you can type WSL. That is if you already have it. Good. Now, so if any of those opens, we can use any of those. It's no problem. You can use any of those. So whichever you have is what we shall use. So once it opens, now you want to clone. You want to clone Noir. So to clone Noir, and you want, let's say you want your programs arranged. For me, I want them arranged in Rust programs. So after I send my command prompt, I'll just copy this and paste cd Rust programs. That is where I want my Noir to be installed. That is where I want it to be installed. So why you want it installed, that is why you cd. So just say cd Rust programs. I want my Noir to be in that directory, Rust programs. Now, so once you are inside that, you now want to clone. I copy this link. This is git clone github.com/, and so on. So I just copy this link and then paste it here. And press enter. Now, so it will now clone. It will clone the Noir repository directly into the directory that you named. In my case, my directory is this. So it will clone it here. This is where now I can find it in the future if I want it. I want to use it, of course, we'll be using it. But it will always be here. So I clone it there. It will take some time. Then after it's done, I cd Noir, because I have now cloned it I now want to get into it. I now want to get into it and use it. So I CD it, I CD Noir. That means I'm getting inside it. Then after that, I now I want to build a project. So I will do cargo run release. No, cargo build, cargo. I see I did CD now. Then after that, I just type CD now, enter. And then after you enter, now do cargo build, a dash release. So this one is just to assist you build a project. So it will compile the project and generate binaries inside the target release directory. So when you do that, there will be this target release directory that is formed. And then once it's formed, we have the project will be generated and binaries. The project will be compiled, and then binaries will be generated inside this folder. It's just a folder. So the binaries will then be generated inside that folder. Now, so we've already cloned Noir, but remember the first step was you have to have Rust first of all, must have Rust installed. If you have Rust installed, you now proceed to install Noir. And so the step is you open command prompt. Or you can even open WSL if you have it, or you just type MCD at the start button of your laptop, and then you have the command prompt, open it. Then now CD Rust programs or any other title where you want your Noir to be installed. The name you want your directory, the name you want your directory to be called. For me, I want it to be called Rust program. So I would CD that and then press enter. After we press enter, now copy this git clone HTTPS and so on. And then paste it there in your terminal. Paste in that terminal, press enter. Give it time to install. Once it's installed, CD Noir, now getting installed. Then enter. Then type cargo build release. Then again enter. Now, so we are done with installing the CLI tool, which you also call the Nago. So that is the next thing we'll install. So to install this Nago, we are still in your command prompt. You're still there. Remember, we had already done this. We already done CD Rust programs. We had already done CD Noir. Now tooling. Yeah. Or if you had closed the command prompt, suppose you close the command prompt, you can even close it and reopen. When you reopen it, you can just copy the entire command and paste it in your terminal, the entire command prompt, and then press enter. Now, so after that, you want to build the Nago project. it's done in the release mode. So you again do cargo build -- release. And then give it some time. And then after it's done running, you now say cargo install -- You can use the command nago at globally from anywhere. You don't need to. So you, for example, you can use it when you're using WSL, you can do it when you're using command prompt, and even visual code, if you're using it, so that you can use it anywhere globally. So that is why I say cargo install path, so that your path is available and you can use it anytime you want it from anywhere. Now, so after you've done with that installation, you may want to verify whether your Nago has been installed, and to verify whether just in your terminal, type Nago version. It will give you the version of your Nago. Now, so after you've installed Nago, you are now ready to begin writing Noir program. You're now ready to begin writing a Noir program, and that is the next step I'm taking. So before that, let's just go through it now practically, so that we try and install. Of course, you've already installed Rust. I also have Rust. And now I want to install Noir and then install Nago. And then after we install Noir and Nago, we now proceed to write circuits in Noir. So I want to do, I just want to open my WSL. First of all, now, so since you already have Rust, and I also already have Rust, we will begin from a step where we're now installing Noir. So I want to go to, let me go to the start button and write WSL. Mine has opened. Let me just now share my WSL. How do I share it? Okay. Yeah, it's here. Mine is, I think you can see it. Let me just enlarge it. My WSL is here. There's a message here, but if yours doesn't have a message, what I'm only interested with is this part. This part is my terminal. So being my terminal, the first thing we said is that for us to install Noir, we begin by CD, then the directory that you want to install your Noir in. For me, I want to install it in in Rust programs. So I don't know whether you still can see it. If you still can see I don't know why there are two. Open the two. Let me just unshare and then open again my WSL so that I'm only, I don't know why they opened the two of them. So I don't know which one I'm sharing, WSL. Just open again, but I have only one to share. So they're opening two at every time I do it. Okay, WSL. This time it's, I think I was opening two at a time. This time I've opened only one. So it's the one I want to share. Yes, so that whatever I do, you can see it. Because if I open two, the problem is I may not know the one that I'm working on. Now, so my terminal is here. So the first thing we said was cd Rust programs, because that is where I want to store my Noir once it's cloned. So I've written cd Rust programs. So when I press enter, I'm now inside that directory. That is why I want to clone. I want it when I clone it, it should go there. So now the next thing is to write the link for where I want to clone from. So it is, the link is here. So git clone https, that is the link. Just copy and paste it there. So if I press enter, now mine already, I already have it installed. It's already installed. That is why it's saying fatal destination path nor already exists and is not an empty directory. So I've already installed it. So for you, you do it because you've not installed. So it will take you through, it will take some time and install. Mine, I had already installed it. Now, so once you install it, the next thing is to cd Noir. cd Noir. So you want to go inside it. And then proceed from there. So just install it, give it some time. Then after you install it, for me, I've already, I installed it earlier. So once you install it and you're still inside the Rust programs, you now want to cd Noir. So you can see I'm now inside Rust programs. Then inside that, I've entered inside Noir. So I'm now inside there. While there, you want to build the project. So first of all, we do cargo build release. So that is what we first do. While inside there, let's just do cargo build release. Cargo build release. Just you can just copy and paste. You have it, so we just type. Now, so you can see what is happening. It's building and compiling, building, and so on. So we give it some time. You can see it's 17 out of 589. It will take some time. It will take some time to do this, but we give it, just wait for it to do it. Just wait for it to run. The command will just assist to compile the project, and at the same time we'll be generating the binaries inside the target stroke release stroke directory. So that's what is happening currently. So you can see what it's generating. These are the things generated. For example, site a crypto commons digest. So it's generating some things of PPV and so on. Generating all this. It has gone up to number 589. So just give it time. It will soon be done. Now, so what we are doing is just installing. We've already installed our Noir. We already cloned it, and so what we are doing is we want to build a project, and at the same time as we do that, want to generate binaries. So that is what is happening currently. It takes long, but it will soon be over. Let's give it like 2 to 3 minutes and see what happens. Yeah, it appears that it's taking long, but let's give it some time. Because that is a procedure, so there's no shortcut. We have to wait until it does it. But for me, I'd already done this process. I'm only repeating for purposes of demonstration, but I've already done this process. So then, just for reasons of demonstration, I'm redoing it. But if it takes long, I would as well stop it because I had already installed this step. But it's not a long process. It's supposed to take at most maybe 8 minutes or less. Now it appears it's taking long. When it reached 105, it appears it's still buildings taking longer. But that is a process. That's what you will do. Since I had already done it, I think I can skip this process. I don't think it will interfere with my program because I had already installed everything. So what I'll do, I'll stop it so that we proceed to the other level. Just after that, after build release, the next thing, just doing it for the purposes of demonstration. So I just closed it and then reopened, restarted. I closed, then I'm restarting it. Now let me share. Okay, it's there. Now after installing, after that, what I want now to install is the Nago. Now to install Nago, again I have to CD Rust programs. That is where it is installed. And then CD Noir. Okay, that is the command. There's a command CD Rust programs, CD Noir, and then that. Then press enter. I'm inside there. Inside there. Now again, I will do cargo build release. Cargo build release. I will do it. This is another time I'm doing it. This is now for Nago. The other one was for the Rust. The other one was for Noir itself. And now for Nago. And this one is a bit faster. I think it picked up from where the other one had stopped. So it began, you can see, so already at 448 out of, just picked up from where the other one had stopped, where I stopped the other one. Now, so this is to build a Nago project. After that, I want to ensure that my Nago command can be accessed globally from anywhere. So I would do cargo install path, cargo install path. That is just to ensure that there's after path, there is space, and then dots, some space, and then a full stop. When you do that, when that full stop is not there, then it will not run. It will give you an error. So let's just wait until this one finishes. It's just it's 496 of 5. It's already in 512 or 575. $526. I'm using WSL. You could be using a command prompt, and they'll be doing the same thing. It's no problem. But whichever you're using, you stick to it to the end. whatever you're using. If you're using WSL, stick to it. If you're using, you could even be using Ubuntu. If you have it, you could be using Ubuntu terminal, or you can use command prompt, whichever you're using, stick to it to the end of the install. Now, if you give it a few minutes, I think it will have installed to the end. Then after this, since we want it to be accessed, we want our Nago to be accessed from anywhere globally, we would then do cargo install path. Cargo install path, that is what will enable it to be accessed from anywhere. So again, I had already installed this, but I'm doing it just for reasons of demonstration. But I had already installed it. So once you have these commands, you can always install it at your own time. Just follow the steps that we just we've been following. So the ones you would then follow. So just maybe a few seconds, and then it will be done. It's now 570 or 576 or 575. It's a few seconds. Now it's good that we all install it. It's good that we all install Noir and then install Nago, just the way we've done, so that when we begin writing zero knowledge proofs using Noir, we have it. Now, so it's about to, it has taken some time to install, but it's just, I think it's now done. Now, so what we were doing there, we had done, that was a cargo build release. So when I want to do cargo install path, so that we have our Nago available globally. And remember, when you write cargo install dash dash path, there's some space and then dot. This full stop here is very important. When you omit it, then it means there's an error. It will not run. So let's just do that. Press enter. There's a mix. Let me do it again. I don't know how it's doing this. So mix. I didn't give it time to run. Okay. Now, so this command is just to ensure that your Nago can be accessed from anywhere. After this, we want to be sure that we install our Nago correctly. So then ask for the Nago version, and we see what if we get a version. If we get a version, it means our installation was done correctly. But if we don't get any version, then it means we did not do our installation properly. So let's wait for this to be complete. And once it's done, we now ask for the version and see whether we can get any version of our Nago. Remember, we began by, we said the first procedure for you to get for you to install Noir, you need to have Rust installed in your machine. And if you have Rust installed, you now begin by cloning Noir. And I showed you how to clone Noir using, I've been using WSL. I said you could also use command prompt or CD. Any of those, there are terminals to install Noir. After installing Noir, you install Nago. That is what we are doing. So we've reached a step where now we have to find out whether our installation was done properly. We do that by finding out what our version is, our Nago version. So if we can get what our Nago version is, it means our installation was done properly. Now, once you are done with that, the next thing will now be to begin writing your circuits or your zero knowledge proofs using Noir. That will be the next step. So we just began by, first of all, installing. Remember when we begin writing our projects, remember where you cloned your Noah, the directory you cloned your Noah to. For my case, and the example that I showed, I cloned my Noah to the Rust programs. So when we are writing our programs again, we will have to CD the directory we cloned the Noah to for us to be able to write our projects. Okay, we give it a few minutes. When it's done, we ask for the version to see whether our installation was done properly. Then from there, we now begin writing our programs, our zero knowledge proofs using Noah. Once it's installed, we are at 217 of 590. So we be patient and give it some time. is at 4:12, just about. Now, if you're installing, if you follow the steps just the way we've done it from step 1 to the current step, then it means your installation will be okay. If you skip any of the steps, or if you mix the steps up, then it means it will not install properly. And again, for you to be sure it has installed properly, you have to ask for the version installed. And if you get the version that has been installed, it means your installation has been okay. But if you don't get, or you find an error, it means there was a problem during installation. But we are hoping that once these steps are used, then there will be no error. So we are at 455, 590. Let's see how long now it takes. So that's about. I think in some 2 or 3 minutes it should be done. It's now 582 out of 590. And it has done it without any errors. So let's see whether we can get a version after it's done. can see it's now done. It has stopped. So now what we can do to be sure that we need to know what version has been installed, the version of Nago. Remember, we began by installing Noir. For those without Rust, you began by installing Rust. Then after installing Rust, you install Noir or Noir. It's pronounced as Noir. And then this time you're now installing Nago. And so let's just know what version it is. And we have the version here. Been told that the Nago version is that, and the Noir version is that, and so on. So that means our installation was done correctly. So what then follows is that we will want to write our programs, our zero knowledge proofs. So for us to write our zero knowledge proofs, we will cd out of all this until we only left with the Rust programs, because that is all we install. So to get out, we just do the same we do for the Rust, cd dot dot, get out of tooling, then cd dot dot, get out of Noir. So we have now the Rust programs. This is where we install our Noir. And so this is where we will be writing our zero knowledge proofs. So today we just wanted to install the programs. Then from there, we will now begin writing our zero knowledge proofs in the next lesson. But today our mission was just first of all to install. So for those who never had Rust, that was the first thing. That's the first thing you do, you install Rust. Then if you have Rust, you skip that process and you begin with the second step. The second step is to install Noir. And then the third step was to install. So after you've installed Noir, Rust, Noir, and then Nago, you're now ready to begin writing the circuits. Zero knowledge proofs, you're ready to begin writing. And so that is where we begin from in our next lesson. So that means in our next lesson, we meet when we'll have installed what is required. And then I'll now be demonstrating how to write, of course, how to begin writing a project. That is very important, how to begin, how to save it, and then how to write it. Those are the steps that are very important, and we need to get to know them from the very start. Otherwise, thank you unless if there is any question. Peter, how are you?
Hello.
Yes.
Is it me?
Yes, it's you, Peter.
Yes, I'm doing fine. I'm quite okay. How are you?
I'm okay.
Yeah, I got into class late.
Yes.
Is there a way I can get a copy of the recording so that I can be able to download and install the requirements by tomorrow?
Yes, it will be shared. Huh?
Yes.
Alex will share the recordings. I think there's a YouTube a link where they normally put all the PDF notes and recordings.
Awesome. Thank you so much.
I don't know whether you have that YouTube link.
Could you kindly share it?
Yes, you are on the WhatsApp group of Web3. Yes, you are there.
Yes.
Yes, if you ask, I think Alex will share it.
Thank you so much.
Okay, welcome.
Yeah.
So let's end it at that. We meet on Thursday from noon, where we'll now be looking at how do we write zero knowledge proofs using Noir, which we've now just installed. And if you've not installed, maybe you install it before that time so that we move together. It will be hands-on as we normally do, so that we demonstrate and move with an example that we can all follow what happens. Okay, thank you.